reviewing.
Good morning, I'm Madam Immaculate. Today's topic will be a Form 1 topic by the name algebraic expressions. So that is what we'll be doing today. Algebraic expressions, it's a Form 1 topic, mathematics. Form 1, and the topic is algebraic expressions. So, algebraic expressions. So in this topic, probably today we are going to deal with algebra, whereby in algebra letters are used to represent numbers. So we say in algebra, in this topic we are going to use letters. We are going to use letters to represent numbers. So we look at examples of some statements to represent numbers. We look at some examples of some statements whereby we are going to see how letters will be used to represent numbers. For example, you can be told to represent this statement in terms of letters. The first statement is the number of days in M weeks. So you are told represent the number of days, in M weeks. In M weeks. So we have M weeks, whereby M is representing a certain number that we don't know. But we know that in 1 week we have 7 days. So in 1 week we have 7 days. So if we are supposed to find the number of days in M weeks, we are going to ask ourselves, what about M weeks? Whereby we just do not know what M represents. So this will come here, we cross multiply there, whereby we'll have, this will be given by 7 multiplied by M, which will be given by 7M days. So this is just an example of how we represent a certain statement using letters. Let us look at another example whereby you can be told, find the expression expressed by a number multiplied by 3. We are given that a number multiplied by 3 and then 6 added to the result. Then 6 is added to the result. So we are going to give this number that we don't know any letter. So you can say maybe let that letter be Z. So a number Z is multiplied by 3. We multiply Z by 3, whereby we get this is 3Z. And then 6 is added to the result. If we add 6, we cannot say that this will give us a 9. That is already the answer. So we have our answer as 3Z plus 6. Now let us see a last example, whereby this one comes mostly. We are told that John is twice as old as his brother Kogo. So we have Roman 3. John is twice as old as his brother Kogo. And their sister Jane is 7 years. And their sister Jane is 7 years. Is 7 years younger than Kogo. Younger than Kogo. So we are supposed write an expression to represent the sum of the ages. Write an expression to represent the sum of the ages. of their ages. So as you look at this question here, we have three people there. We have John, we have his brother Kogo, and their sister Jen. So let us see how we deal with this one. So we have John, we have their brother Kogo, and we have their sister Jen. And we are told that John is twice as old as his brother Kogo. So if we have John being twice as his brother Kogo, we can say let the number of age of Kogo be represented by letter X, and then the brother now, since John is twice as old as Kogo, John therefore will be 2x, because now he's twice as old as Kogo. And their sister Jen is 7 years younger than Kogo. Kogo is X, meaning if Jen is 7 years younger than Kogo, it will be Kogo's age, which is X minus 7. So that is how we represent the ages of John, Kogo, and Jen. So John is 2x years, Kogo is X years, and Jen is X minus 7 years. So we are told, write an expression to represent the sum of their ages. So if we are supposed to find the sum of the ages, we are just going to add these ones. So this will be 2x plus 2x the age of John plus x the age of Kogo plus x minus 7 the age of Jen. So we collect like terms whereby we have 2x plus x plus x. This gives us 4x minus 7. So this is the expression, yes. This is the expression that represents the sum of their ages. So let us now look at, we've known how to represent expressions using letters. I want us now to look at how we simplify algebraic expressions. Simplification of algebraic expressions. So this topic usually confuses most of the students just because they use letters instead of numbers, and they know that mathematics is usually more about numbers, but we can also use letters and it is fun. So let us look at how we represent, how we simplify algebraic expressions. Simplification of algebraic expressions. So this is a Form 1 topic, simplification of algebraic expressions. So having that as our subtopic, we first of all have to identify like and unlike terms. In simplification of algebraic expressions, you must know how to identify like and unlike terms. So let us look at how we identify the like and unlike terms. And unlike terms. So you can be given, for example, some terms whereby you are told to pick the term which is not the like term. So let us give certain examples. The first example we have, maybe you can be given 3a, 5a, then we have 2a squared, then we have 7a and 9a. So in those terms we have how many? 1, 2, 3, 4, 5 terms there. So we are supposed to identify the unlike term, the term which is not like the other. So as you can see, we have 3a, 5a, 2a squared, 7a and 9a. Therefore the term that is not like, it's 2a squared, because as all the others we have just a raised to power 1. Like it's just an a, it's not a squared, a cubed. So the term that is not like it is the one that has an a that is raised to power 2. Therefore 2a squared is not the like term there. So I can give another example. Maybe we have a squared b, then we have ab, then we have ba squared, then we have 5a squared b, and lastly we have 6ba squared. So let us look at that example, the second one. Let us now see if we can identify like terms. As you can see, in all the terms we have letters A and B, but each letter has a number that is raised to the power. For example, in the first term, our A is raised to power 2, and B, it's not raised. That means it is just to power 1. So we have A squared B, this one is AB, this one is BA squared, which means our A is also raised to power 2, and our A is raised to power 2 here. So we have also here a is raised to power 2 also, and lastly a raised to power 2. Then b's, we have a single b, but this one, our a was not raised to power 2, and the rest were raised to power 2, meaning the term that is unlike, it's the ab, because we have our a not raised to any power. So let us, now that is how we identify like and unlike terms. Maybe I give a last example to see if we can note that. We have the last example. Roman 3, we have maybe 2CD. Then we have DC. Then we have negative CD. Then C squared D. And lastly, negative 3 over 4 CD. So if you look at those terms, we are going to, we specifically look at the letters. We have letters C and D in each and every term. And each C and D, in most of the terms, they are singles. They are not raised to any power. So we have CD here, CD, DC. It's all the same because this is just multiplication. It is just like 3 multiplied by 4 and 4 multiplied by 3. They both give you the same answer, which is 12. So it doesn't matter which letter starts. Whichever letter starts, as long as it is multiplication, it's just the same. So CD, DC, they're all equal. CD there, then we have C squared D. So the term which is unlike is the C squared D, because our C is raised to power 2 and the rest they are not raised to any power. So that is how we identify the like and unlike terms. So before you start even simplifying algebraic expressions, you have to know how to identify the like and unlike terms, because you'll be needed to know the like and unlike terms, whereby you'll be needed now to use them to simplify that expression. Let us now look at a certain example whereby we have to simplify. So simplify, just simplify. The question is simplify the following. We have 2a plus 3b plus 4a minus b. So here, as we have that one, if we are supposed to simplify, we first have to collect the like terms. So let us collect the like terms there. We have terms that are represented by letters A and other terms that are represented by letter B. So let us use now, we have, this is 2A, we are going to collect like terms, plus 4A, then plus 3B, and then minus B. So if we have that way, we can now add the like terms, whereby 2A and 4A can be added to each other because they have the like terms. So this is 2A plus 4A, this is 6A. Then 3b minus b, this is 3 minus 1. This is just the same as 3 minus 1, whereby we get a 2. So this will be plus 2b. So that is our answer in the first example. Let us look at another example. Example 2, whereby you can be given 0.5r plus 0.85 and then minus 0.1r. So we have two terms there. We have the terms that are represented by letter R, and the other one, it is not represented by any letter. So that one will stand on its own as a term. So we're going to collect like terms there. We have the R here and the R there. So this is 0.5r. And then we are not going to use this sign, addition sign, because the sign comes before the unlike term. So we're going to use 0.1r, whereby the sign before it is a negative. So this will be minus 0.1r and then plus 0.85. So we add the like terms there, which is, we simplify the like terms there, which were supposed to subtract 0.5 minus 0.1. This is 0.4r, then plus 0.85. So this becomes our answer. That is how we simplify algebraic expressions. They are as easy as that. Let us look at another example whereby we are supposed to have 2 over 3a, 2 over 3a minus 1 over 8b, and then plus 1 over 6a, plus 1 over 6a. So we have terms there. We have terms that are represented by letter A and letter B. So let us now do this one. So this will be given by, first of all, as you can see, that question is a fraction. So we are supposed to just add or subtract as we usually do it using the fractions, the normal way we deal with fractions. So we are going to find the LCM of 3, 8, and 6, whereby the LCM of 3, 8, and 6 is 24. So we have 24 here all over. Then we just do it the normal way. 24 divided by 3, this will be 8. So we have 8 multiplied by 2a there. Then minus 24 divided by 8, that is 3. 3 multiplied by 1b, which is the same as b. And then plus 24 divided by 6, that is 4. 4 multiplied by 1a, which is the same as a. So we open the brackets there, whereby we are going to get this is 16a minus 3b plus 4a all over 24. And then we collect the like terms. There we have an a and an a on the numerator. So this is 16a plus 4a. So this will be written as 16a plus 4a minus 3b all over 24. So we add the like terms. We have 16 plus 4. This is 20a minus 3b over 24. So you can leave your answer as that. That is also correct. Sorry, this is 20a. 20a. So you can leave your answer as that, or also you can simplify further or differentiate those ones into two fractions. This one can also be written as, so if you leave your answer there is also correct. You can also simplify further and say this is the same as 20 over 24a minus 3 over 24b. This is because all the numerators there are they have a common denominator, which is 24. Then after this you simplify. This is by 4 5, by 4 6, by 3 1, by 3 8. So this gives you 5 over 6a minus 1 over 8b. So this answer and this answer are all the same. So you can leave the answer where you wish, but any of those is still correct. So let us now look at how we've known how we simplify algebraic expressions. So the thing that you need to know as a student is how to identify the like and unlike terms, whereby you are supposed to add or subtract or even multiply, whichever thing the question asks, but as long as you know that you are supposed to use the like terms. If you confuse, for example, you can be given a question like, let's use these terms here. When you are given like maybe that is 5a, and then minus 2a squared, and then plus 7a. And then you come here and give me the answer as this. You say this is 5 minus 2, because you see all of them are a, and you've not noticed that 2a squared is not a like term. So if you say this is 5 minus 2, you give me 3, then 3 plus 7, you tell me this is 10a, or even you say this is 10a squared, all this will be wrong, because you've confused or you've added unlike terms. You've added terms that are not like. So this one was supposed to be done as 5a plus 7a, which is 12a, then minus 2a squared, and this is the answer. So you don't have to add terms that are not like. So let us now, so in like terms, we've said to really know what like terms are, we say that like terms, they have the same letters or letters that are raised to the same powers. If you have letters like, if we had another term here, maybe, we say another term, let's say we had a term like maybe 10a squared. So we could have terms that we have 3a, 5a, 7a, and 9a. Those are like terms. Then we have 2a squared and 10a squared will be like terms, because they have letters that are raised to the same power. So that is how we deal with simplification of algebraic expressions. We've known how to identify like and unlike terms. We've also known how to simplify even the ones that are using fractions. I want us now to look at how another example, also a bit complicated, not as simple as it was, how we simplify algebraic expressions, but they're all done the same way as long as you know how to pick like and unlike terms. So let us look at this one. A squared b, let's call this example 1. A squared b plus 2ba plus 3ba squared and then minus AB. So first of all, we have to identify like terms there. We have a squared b, we have BA here, we have BA squared there, and we have AB there. So as I said earlier, it doesn't matter which letter starts. Any letter starting or which comes before the other one, as long as they're in the same term, they just mean the same. So this one, let us rewrite this in the same way so that you don't confuse. This is saying the same as saying a squared b plus 2BA, and then plus 3. This one can also be written as 3A squared B, as long as you don't confuse the power and write, maybe for example, you say that this one, you say this is 3AB squared. That will be very wrong. So it is 3, since the letter that is raised is A, this is 3A squared B, and then minus, since here we started with B and these are like terms, this will be the same as also saying BA. So as we have there now, let us collect like terms. We have A squared B here and A squared B here. So this will be A squared B plus 3A squared B, and then plus 2BA minus BA. So if we have, we've collected like terms like that. So we have that way. This is A squared B, 3A squared B. This is just the same as 1A squared B. So 1 plus 3, this is 4A squared B. And then 2 minus 1. This is BA is just represented as 1. We just cannot write 1 there. It will be repetition. So 2 minus 1, we have this is, it will be plus BA or AB, whichever, it is still the same. So that is the answer there. So here, the examiner was just trying to confuse you by starting with the letters or by mixing the letters differently. But if you are a good student, you should know that you should identify like terms by looking at the letters that are raised to the same powers. Like here we had A squared, then B. Here we also had a B, which is not raised, and an A squared. So meaning that this one and this one are like terms. Then here we had a BA and an AB. So those ones two are also like terms. Let us look at another example. I'm doing as many examples as possible so that you will be able to understand and tackle such questions. So we have PQR. This is example 2. PQR plus RPQ plus QRP, and then plus 2PQ. So we have that question there. So we have terms that are represented by PQR, RPQ, QRP. All these terms are equal. This is just the same as saying P multiplied by Q multiplied by R. Then next, this is, let me just demonstrate that one, then we'll wrap. So this is the first term is the same as saying P multiplied by Q multiplied by R. The second term is the same as saying R multiplied by P multiplied by Q. The other term is the same as saying Q multiplied by R multiplied by P. All these are equal because they'll just give you the same answer. So we have terms which are equal. We've seen that. So the first three terms are equal, whereby this is the same as saying 1 PQR, 1 RPQ, and that one. So if we add, this is 1 plus 1 plus 1. This gives you 3. You can write any, you can use PQR or RPQ, whichever. They're just the same. So let us use PQR, then plus 2PQ. This is the answer because you cannot add this one and this one. This term does not have an R. So we have that as our answer. Let us look at the last example in simplifying. Then the last example, let us say this is y cubed plus 3y. This is example 3. Y cubed plus 3y plus 2y cubed, and then plus y. So this one looks a bit simpler. We have y cubed there and we have another y cubed here. So we collect like terms, which will be y cubed plus 2y cubed, and then we have a y here and a y here. So this will be plus 3y plus y. So y cubed plus 2y cubed, this will be 3y cubed plus 4y. So that gives you the answer. So that is how we simplify algebraic expressions. The best thing is you just have to note and know the terms that are like and the unlike terms. Whichever way, the letters can be rearranged, or we can start with, for example, in this example, we saw that here they started with an a squared b, and here there was a b a squared, which a student may say that those terms are not the same, since they were expecting the letters to start with all the arrangement of letters should be equal, but it is not a must. As long as the letters are raised to the same powers, those are like terms. So I want us now to look at how we solve algebraic expressions using brackets. So let us look at how we solve algebraic expressions using brackets. Having known how to simplify brackets will be much easier, and they simplify your work. So using brackets to simplify algebraic expressions. So use of brackets. Use of brackets to simplify algebraic expressions. So let us look at how we deal with that one, use of brackets to simplify algebraic expressions. And the use of brackets to simplify algebraic expressions, that process of using brackets is called expansion. So this is just the same as saying expansion. In most cases, you can be told expand the following, then you are given a certain question. So let us look at how we remove brackets to simplify algebraic expressions. We're just going to start with the first example there. So let us have 3 to bracket r plus s, and then plus 4 into bracket r plus s. So we are supposed to remove those brackets and then simplify. So if we have that one, brackets, you know that they also mean it is just the same as multiplying. So let us look at how we solve that one. So this one will be given by, this will be, if we open brackets here, this will be 3r plus 3s, and then plus, we open brackets there, 4 multiplied by r, this will be 4r, and then plus 4 multiplied by s, this will be 4s. And then from there we collect like terms. We have an r here and an r there, s and s. So this will be 3r plus 4r plus 3s plus 4s. So if we add 3r plus 4r, this is 7r plus 3s plus 4s, this is 7s, and that becomes your answer. So that is how we remove brackets to simplify algebraic expressions. Then let us look at another example. We have 4 into 2a plus 3. 4 into 2a plus 3. And then we have minus 3 into 5a minus 6. So let us look at how we solve that one. You should be careful with the signs, because if you don't, you'll miss it out. So let us see how we do this one. 4 multiplied by 2, this will be 8a. And then plus 4 multiplied by 3, this will be 12. And then we have negative 3 multiplied by a positive. So a negative, when it's multiplied by a positive, that will be a negative. So here we have negative 3 multiplied by a positive 5. This will be a negative 15a. And then a negative multiplied by a negative, that gives you a positive. So if we have a negative 3 multiplied by a negative 6, that will give you a positive 18. So this will be plus 18. So students should be very careful here, because here, in this sign here, someone could have just said this is 3 multiplied by 6, and since there is a minus there, they just put a minus. That one will give you a very wrong answer. So you have to be careful with the signs. Just note that a negative, when it's multiplied by a negative, you get a positive, and then a negative multiplied by a positive, that you get a negative. So let us now continue. After you've identified that, we collect now the like terms. We have an a and an a here, and then these numbers that they do not have letters. So this will be given by 8a minus 15a. We use the sign that is before the term that is like. Then we go plus 12 plus 18. So 8a minus 15a, someone could tell me it is impossible, but it is not. We get our answer as negative 7. So 8a minus 15a, that gives you negative 7a. And then plus 12 plus 18, this gives you 30. So your answer can be written as that, or you can also decide to start with 30, you can also say this is also the same as saying 30 minus 7a. It is still the same. This and this are still the same. This is just negative 7a plus 30, or 30 minus 7a. All are still the same. But I wanted to stress much on the signs here, on this example. So I've said when you multiply, let me just note it down somewhere. When a negative is multiplied by a negative, we've said that we get this is a positive. And when a negative is multiplied by a positive, the answer this here gives you a negative. So make sure you note those two there, because they are usually used in most cases when we use brackets in algebraic expressions. I now want us to look at another example also. Let us see how we'll solve this one. Our today's topic was algebraic expressions, and it's a Form 1 topic whereby we use letters to represent certain statements or certain numbers. So let us look at our third example, how we use brackets to simplify algebraic expressions. So let us have like, we have 4 into x minus 1 4 into x minus 1 plus, no, let's say this is a positive there, then plus 3 into x minus 1, and then all over 6. So you have to simplify that. So we start with the numerator. Starting with the numerator, we open the brackets as normal. So this will be given by 4 multiplied by x, that will be 4x. 4 multiplied by 1 will be plus 1. They're all positive. Let me add here, if you take a positive multiplied by a positive, you just get that is a positive. So let us look at that. So this was a positive and a positive, a positive, a positive. That's why you've seen I've just added like that. Then we go, then 3x, 3 multiplied by x, that will be given by 3x, because they're all positives. And then a positive 3 multiplied by a negative 1. A positive multiplied by a negative, that gives you a negative. So this will be minus 3 all over 6. And then thereafter we collect like terms, whereby if we are supposed to collect like terms, we have the terms there that are with x and the numbers alone. So this will be 4x plus 3x, and then plus 1 minus 3, plus 1 minus 3, plus 1 minus 3, all over 6. And then we add there 4x plus 3x, that will be 7x. So this will be 7x plus 1 minus 3, that is the same as saying 1 minus 3, which will be minus 2. So this will be a negative 2 then over 6. So that is your answer in search. Just make sure you note the signs there. After you've noted that, it will not be of any problem to you. We look at our last example on how we remove brackets to simplify. Our last example. Let us say we have a half w into 8 w minus 2m, and then plus a third into 6m minus 3w. So if we have to solve that one, we have the number that is outside the bracket, so we have to take a half multiplied by 8, which is this is just the same as if we use the long method. This is a half w multiplied by 8w. So it will simplify automatically. That will be given by 2, 1 by 2, this is 4, and then we have w multiplied by 4w, which will be given by 4w squared. But you don't have to use the long method. You just simplify. So this a half w multiplied by 8w, this will be given by 4w squared minus, because this is a positive multiplied by a negative, automatically that gives you a negative. So we have a half w multiplied by 2m, that will be given by a half will cancel out to be 1, then we will remain with wm, and then plus, because this is a positive and a positive. A third multiplied by 6m, that will be 2m. And then a positive and a negative, that gives you a negative. Then a third minus 3w. So this, if you multiply here, a third will cancel out, will remain with w alone. So if we have that one, let us look if we have like terms. This is w squared, this is wm, this is m, and this is w. So in that term, we do not have any like terms because they are all terms of their own. This one is w squared, this is w. So we cannot say that these are like terms, they are not. And this one we have wm, and this one is 2m. So already this is your answer. You stop there. So that gives you the answer to simplification of that question. So at this point, we've known how to use letters to represent algebraic expressions. We've known how to simplify simple algebraic expressions. We've also known how to use brackets to simplify algebraic expressions. I want us now, we said that when we use brackets to simplify algebraic expressions, that one is called expansion. I want us now to look at the last thing, whereby we are going to factorize. Factorization is the reverse method of expansion. Instead of now using brackets, we are going to come from the reverse method. For example, you can be given this and you have to come back to this. So let us look at how we factorize algebraic expressions. So the next thing is factorization of algebraic expressions. We see how we factorize now. So we've done expansion, we now have to do factorization. In algebraic expressions, you have to know how to do any of them because some questions will require you to use both. So let us now look at factorization. So I've said factorization is the reverse method of expansion. Let us start already by an example. So if we have an example like 3p plus 3r plus 3q plus 3r. So in factorization, you have to look at what is common in those terms that you are given. So as you can see, all terms have a common number, that is 3. But there are two terms that are alike there. So we have an r here and an r there. So you can start by adding and making sure that you do not have any other like terms. So let us add that. This will be given by 3p plus 3r plus 3r. This gives you 6r and then plus 3q. So having that, we've simplified. This is now simplification. Let us now factorize. After we have found this is, you could also leave this as your answer, but you are supposed to factorize. In short, you have to put your answer in brackets form. So we are going to look at what is common in all these three terms. We can get a common number, which is 3. Because we can get a 3 here, we can also get a 3 here, and we can get a 3 there. Then we open our brackets there. So we ask ourselves, if we take 3p, we divide by 3, what are we going? This is just the same as saying 3p over 3. 3 will cancel out, will remain with p. And if you open the bracket, this will be the same as saying 3 multiplied by p, which will still take you back there. That's why I said it is the reverse method of expansion. So we continue there. This will be plus 6 divided by 3, this is 2. So we have a 2, then we have an r there. So if we open, we confirm, we see if we've gotten it right. If we open the brackets here, this will be 3 multiplied by 2r, which will give you 6r. And then lastly, plus 3, it already cancels out. Then we have a q there. So as you can see, we've used brackets and we factorize. So this gives you the answer. This is the factorization of this term here, the question, which was 3p plus 3r plus 3q plus 3r. So this is the simpler form of that. Let us look at factorization now. I just wanted to show that one. Then we look at factorization by grouping. Factorization by grouping now. As long as you know how to use the brackets, it will all be simpler for you. So let us look at how we factorize by grouping. You can be given a question and you are needed to group, or you factorize that question by grouping. So we have an nx, example 1. This one also applies when you reach in form 3. We're going to use the 3 algebraic expressions or the equations whereby you are supposed to apply them after this knowledge. So we have an nx minus 2n and then plus 3mx and then minus 6m. So when you have that question, you remember when factorizing, you have to look at what is common in certain terms. So we can group this question into two. We have an nx here and a 2n, whereby we can get the term that is common, we can get an n in the two terms. While here we have 3, we can get a 3 here, we can also get a 3 there, and we also have an m here and an m there. So we're going to group this this question into two. So we have the first two terms whereby the common letter is n. So we'll open our brackets there. We have our n will be outside the bracket, then we open our brackets. So nx divided, this will give you an x, because if you open the bracket, this will be n multiplied by x, which will still give you an nx, and then minus 2n divided by n, this will be 2. Then we close the bracket, then we open another bracket for the other two terms. So this will be plus, we have a 3 is also common here, and we also have another common letter which is m. So we're going to have 3m outside the bracket like that, and then we have, so 3mx divided by 3m, we are going to remain with x there, and then minus 6 divided by 3, this is 2, m will cancel out, so we are going to get that one. So after we've gotten that one, as you can see, what is in the bracket are all equal. We have an x minus 2 and also an x minus 2 there. So if we have x minus 2 and another x minus 2, we usually say mathematically it is put this way. We usually take the letters or the terms that are outside the bracket and place them in one bracket. So we have an n, then plus 3m. The ones that are outside the bracket, place them in one bracket, and then since you have two equal brackets or two same that are all equal, we are just going to use one bracket. So we have x minus 2. So this is how, so this is your answer. This is how we express that one. We don't use, we have two brackets here, so we're not going to put x minus 2 and another x minus 2. We just use one, and then the letters or the terms that are outside the bracket are placed in one bracket. And remember, in between the two brackets, we do not have any sign. So it will just remain like that. So that is how we factorize by grouping. That is the first example. Let us look at our last example. Our last example, let us say we have xr minus ym, and then plus yr, and then minus ym. So this is our example 2. We are supposed to factorize there by grouping. So if you look at those terms, we can group this into two different groups. We can use the r and r. We place that one in one group, or we can also use m and m. So we have xr plus yr. So this will be given by xr plus yr. We've grouped that one, whereby our common letter will be r, and then minus xr minus ym plus yr minus, sorry, this was supposed to be xm. So if we have that one, we still have our r there, and then ym and xm. So minus xm, this one, and then minus ym. So as you can see, I've just collected the leg terms. I've not changed anything. This was xr plus yr, and then minus xm, and then minus ym. So from there, now we are supposed to group the first two terms. They have a common letter r, so we remove r outside the bracket, and then we're going to have our x plus y there. Then we close the bracket, and then in our next two terms we have a common letter which is m. So we are going to say, maybe if we have to put a negative there, you be careful with the signs, remember. So this, if we place a negative m, then we open bracket, so that we have a negative here. Remember, we have to multiply a negative with a positive, so we are going to get a positive x. Let us confirm if that is true. This is a negative m multiplied by a positive x will give you negative xm, which is correct. And then we're going to have a positive here, Because if we place a negative, remember we're going to multiply a negative and a negative, which is supposed to give you a positive, and our sign here is not a positive, so we're going to have a positive there, whereby if we take a negative m multiplied by a positive something, we're supposed to get a negative. So it will be plus, then ym divided by m y. So as you can see, these two brackets should always look the same. If you have these brackets that are not equal, you know you've just gone wrong somewhere. So the two brackets should always give you the same digits or the same letters. Even the signs in the brackets should always be equal. If we had here x plus y and here x minus y, so something is wrong somewhere. So if we have the brackets that are equal like that, so we're going to get this. The ones that are outside the bracket, we place them in one bracket, so that is r minus m. And then we are not supposed to place any sign in between the two brackets, then another bracket, x plus y. So that is our answer. That is how we factorize by grouping. So at this point, we've reached our final thing that we're supposed to do. So our today's topic, or what I've taught today, I've taught you people on how to use letters to represent numbers or certain statements. We've also looked at how we collect like and unlike terms, how we identify the like and unlike terms. We've also looked at how we simplify algebraic expressions. We've also looked at how we use brackets or the removal of brackets to simplify algebraic expressions, which you say that one was called the expansion of algebraic expressions. And lastly, we've also looked at factorization of algebraic expressions, and we've also looked at how we factorize by grouping. And I also mentioned something about the signs, whereby I said a negative and a negative multiplied by a negative, that gives you a positive, and a negative multiplied by a positive, that gives you a negative. So that is all what we were supposed to learn today. Thank you very much. I hope you've learned something new today. See you next week. Thank you.